There are parts of the universe where space starts to behave differently, in the vicinity of massive black holes. How did they form, and when? Are black holes responsible for the structure of the universe? Did they help to bring about the birth of the galaxies? This is the beginning, and this is the end. Anything that comes too close to a black hole will be sucked up and disappear forever. Researchers at the Max Planck Institute for Extraterrestrial Physics near Munich are trying to delve deep into the secrets of black holes. They've already made one sensational discovery. Recently, they were able to watch a star being devoured by a black hole.
It doesn't just go gulp and the star is gone. This process goes on over many years. In those years, the brightness of the black hole, or rather in the vicinity of the black hole, was much greater than before. We were able to observe it as a burst of brightness over many years.
These images, says Peter Predale, show the death of a star. The enormous gravitational force of the black hole literally tore the star apart and sucked up the fragments. The process resulted in the emission of a massive burst of X-rays. The radiation was detected by X-ray satellites orbiting in space. This gave astronomers a way of actually observing how black holes swallow up the gas around them and grow in size. For decades, astronomers have been debating the question of whether or not our galaxy, the Milky Way, has a black hole at its center. Researchers at the Max Planck Institute have been able to prove that it has. But Reinhard Genzel and his team had to overcome some cosmic barriers along the way.
The entire Milky Way lies between the Earth and the center of our galaxy. There's a huge amount of material in between that effectively screens out or absorbs the optical radiation. So we had to look at wavelengths that can penetrate that interstellar rubbish heap.
They were helped in their search by the European Southern Observatory's Super Telescope, located in Chile. Together with French scientists, the Max Planck team developed an infrared camera for the telescope. It allowed them to peer through the cosmic dust clouds into the very heart of the Milky Way. They were able to see how stars in that area were forced into tight orbits by an invisible mass. The researchers concluded that the mass could only be a gigantic black hole. Another team of scientists at the Institute can only dream of making such detailed observations. They are astrophysicists looking for black holes in the visible light of other galaxies. They use complicated mathematical models to deduce the movements of the stars from the light spectra they emit. These astrophysicists want to find out if there's a massive black hole hidden in every galaxy, and what the relationship is between black holes and the mass and shape of galaxies. From these findings, they're able to draw conclusions on how black holes influence the development of galaxies. Recent observations have indicated that the short but intense bursts of energy known as gamma-ray bursts, or GRBs, may be byproducts of the formation of black holes. These gamma-ray bursts in deep space point researchers to places where black holes might have been born. But such cosmic births are rare and of extremely short duration. This coming autumn, NASA will be launching SWIFT, a satellite specifically designed to observe gamma-ray bursts. The Max Planck team will be using its data. They hope to determine just how black holes formed in the early universe.
When we observe gamma-ray bursts, we're looking at objects that are very far away. It could be that in the next year or two it will turn out that GRBs are the most distant objects we've ever observed. That will allow us to draw conclusions as to what was formed first.
Which came first, black holes or galaxies? That particular puzzle may never be solved, but it is clear now that astronomers will be making enormous progress in the coming years on their way to the furthest reaches of our universe and the origins of existence.